Hello friends, welcome back to MeshMind. In today's video, we are going to learn relay interfacing with 8051 microcontroller and its programming. First, we will understand what a relay is and why we need it. Then, we will see how to connect a relay with the 8051 using a transistor driver circuit and diode protection. After that, we will write and explain the complete embedded C program in Keil to control the relay. Finally, we will also test the simulation in Keil Microvision debug mode. So let's get started. First, we see what is relay. Relay is basically an electrically operated switch. You send a small current into its coil and the relay closes or opens a separate high power circuit. In other words, a tiny microcontroller signal can magnetically switch on a lamp, motor, or other heavy load without the micro ever touching the high voltage. It gives the microcontroller and the high power device electrical isolation. The relays coil and contacts are separate circuits. Most relays are electromechanical. They have a coil that pulls a metal armature. When the coil is energized, the armature moves and flips the contact. For example, in the up-powered state, a relay armature connects the common contact to the normally closed contact. When energized, it moves to connect common to the normally open contact, turning the load on. Common relay type is the SPDT, single pole double through relay. It has 5 pins. 2 coil pins, 1 common, 1 NC and 1 NO pin. By wiring the load between common and NO, the relay will connect them only when the coil is powered. Next is hardware setup. You cannot hook a relay coil directly to an 8051 pin. The 8051 IO can only source sync about 15 mA, but a typical 12 volt relay coil needs on the order of 50 to 100 mA to pull in. Also, when a coil is de-energized, it generates a high voltage spike that can damage the microcontroller. To handle this, we use a transistor driver and a flyback diode. First, 8051 to transistor. Connect port 2.0 on the 8051 to the base of the NPN transistor through a resistor, typically 4.7 kΩ. This allows the microcontroller to control the transistor without being overloaded. Then transistor and relay coil. Tie the transistor's emitter to ground and its collector to one end of the relay coil. The other end of the 12 volt relay coil goes to plus 12 volt supply. In this setup, when P2.0 goes high, it switches on the transistor, letting current flow through the coil from plus 12 volt to ground and energize the relay. Then flyback diode. Place a diode across the coil. When the coil is turned off, its collapsing field generates a voltage spike. The diode safely clamps the spike and protects the transistor and MCU. Then load connection. Finally, wire your load like a lamp, motor, etc. through the relay contact. One side of the power line goes to the relay common terminal and the NO terminal goes to the load, which returns to the other side of the power. When the relay activates, common connects to normally open and powers the load. In the AC example, you had wired 220 volt AC line. This step ensures the small signal from the 8051 controls the transistor, which drives the coil, and the diode and proper wiring protect the microcontroller while switching the load. Why use a transistor and diode? Simply put, the 8051 pin current is too small to drive the relay coil directly. The transistor acts as a current amplifier or switch, handling the 50 to 100 mA and 12 volt needed by the coil. The diode is mandatory for inductive loads. It prevents the coil voltage spike. Let's write the program. First, hash include reg51.h. This includes the 8051 SFR special function registers definitions for Keil. Then S-bit relay pin P2 cap 0 gives us a readable name for port 2 bit 0, our relay control pin. Then start the main function void main. Then while 1, we enter while 1 to repeat forever. Setting relay pin is equal to 1, active high logic, activates the transistor and turns the relay on. Then delay pauses about 1 second. Next we set relay pin is equal to 0 to turn the relay off and delay again. This on-off cycle repeats continuously. Delay function. The delay routine is just nested loop to waste time. It's a software generated delay. Simulation in Keil. We can test this code using Keil built-in simulator. First, build a project. Ensure the 0 errors and 0 warnings. Then on debug. Start the debug session. This loads the program into a Microvision simulator. In debug mode, open the IO port simulation window. Then run the program and observe. Here you can see as the program executes, P2.0 will flip between 0 and 1 every second. In this video, we learn that relays let an 8051 microcontroller controls high voltage or high current loads using low power signals. We saw how an electromechanical SPDT relay works with a coil and common NC-NO contacts. Then in software, we wrote a simple embedded C program to toggle the relay on off every second and explained each part of the code. Finally, we simulated in the Keil Microvision debugger and confirm P2.0 was toggling as expected. Next video, we will move on the 7 segment display interfacing with 8051 and its programming. This will be really exciting as well start displaying numbers directly on hardware. So stay tuned and don't forget to like, share and subscribe to keep learning with us. Thanks for watching. See you in next one at MeshMind.